สวัสดีครับผมอาจารย์ปลายจากวิทยาลัยอุตสาหกรรมการบินนานาชาติสจล So obviously when we talk about aerospace engineering we talk about anything that stay airborne could be creature or machine that stay in the sky. This could include insects, birds, aircraft or even satellite in the orbits. So aerospace engineering in general consists of aeronautical engineering, which focuses on atmospheric flight. This could be airplane or any creature living in Earth's atmosphere that flies. And on the other hand, we have the astronautical engineering, which focuses on satellite or any object which stay out of the Earth's atmosphere. So for my part, I'll talk about the aeronautical engineering. So let us first take a look at the diagram of this airplane. So just like when a car is driven on the road, there is a friction between tires and the road. And in the case of an airplane, there is a friction between the air around an airplane and the airplane skin. Because of this, we have drag force on an airplane, which kind of pulling the airplane backward. So if the airplane has to fly somewhere, we then need an engine, which you can see here. And so we need an engine to provide thrust to overcome the drag force. So this way, the thrust can be generated to counteract the drag force generated by the friction. Because an airplane must also carry its own weight as well, as you can see here. Usually for an airliner, at least you would need to carry pilot, fuel, passenger, and any other necessary item which would make the airplane fly at all. And so, in order to counteract the weight of an airplane, we then need a wing to provide lift force. And so as you can see here, we have the four forces on an airplane. Now that we have established four forces on an airplane, which serve as a fundamental knowledge, we then narrow down to different specialization in aeronautical engineering. Just now we talked about thrust being produced by an engine. And so when we talk about thrust and engine, then we think about the aircraft propulsion, which in this case, as you can see in the figure down here, it is a test run of an engine of a Spitfire airplane. And so next, also if you see from the four forces diagram, you will also notice that there are four different forces acting on an airplane. And so in order to make sure that the airplane can withstand these forces throughout the flight, the subject of aircraft structure must also be considered as well. If you look down here, you then see the test of the wing. So you can see that the wing is being loaded by a certain set of weight and then being released. This is so that the team could test out the stiffness of the wing, essentially. And so in the area which I'm teaching is the aerodynamics. And as you can see, aerodynamics is generally used for problems arising from flight and other topics involving the flow of air. So you are essentially studying the interaction between the air around the airplane and then the airplane skin itself. So before I finish this video, I would like to walk you through the application of aerodynamics. So if you look in this figure right here, you are looking at Cessna aircraft, and the term that I'll be using is the wing section. And the wing section is essentially when you cut off the wing of an airplane and then you look in this direction, then you see the cross section of a wing, and that is wing section. Now you are looking at the wing section of an airplane being tested inside a wind tunnel. The shape of the wing section, as you can see here, a streamlined shape, is manufactured such that the air pressure on the bottom surface is higher than the air pressure on the top surface, and as a result of this, lift force is generated as the air tries to move from a high pressure region to a low pressure region. As the wing section increases its pitching angle, as you can see here, the lift force increases as well. However, there is a limit to that. So as mentioned earlier, drag force which pulls the airplane back is due to friction between air and the airplane skin. So when the wing section is pitching at very high angle, as you can see here, the air on the top surface separates from the wing, and this is known as stall, which happens when the flow is no longer attached to the wing section. In aerodynamics,
The phenomenon is known as flow separation, which causes the lift force to drop and the drag force to dramatically increases. This scenario is not good as the lift force may not be sufficient to keep the airplane airborne. Because of this phenomenon, there have been many attempts in the world of research to prevent flow separation. For example, a method called active flow control is used to reattach flow to the wing. Given that the flow is reattached to the wing surface, the drag can be significantly reduced. In some cases, drag reduction is accompanied by an increase in lift force. In general, an increase in lift force benefits the airplane during the takeoff and landing. Now, if you look at this figure right here, this figure right here shows the wing section without active flow control. And so as you can see here that there is certainly flow separation occurring on the top surface of the wing section. On the other hand, as the active flow control is activated, you can clearly see that the flow flows smoothly on the top surface of the wing section. And so in this case, we say that the flow is reattached to the wing section.